Hi there. So welcome to Introductory Statistics. As you know, we're going to be using the OpenStax statistics book. So here's a picture of the book here. So the first chapter talks about sampling and data. So as we get into different kinds of sampling, we first need to look at some definitions in statistics. So we need to look at what is statistics, probability, and other key terms we're going to use in this class, okay? So the first definition, extremely important, is what is statistics. So we see statistics every day in our lives, in the newspaper, on the news, at our jobs, no matter what you're doing, if you're working in business or healthcare, there's lots of different data and statistics that we're going to see. Now, especially in healthcare, there's a lot of data-driven decisions and evidence-based practices. So it's important for us to understand some of the terminology in statistics. So here's our definition of statistics. It is the science of collecting, organizing, analyze, and interpreting data in order to make decisions. So here's some other, another short video. I'll be using some of these videos throughout the course. They're called Against All Odds, and I'm going to let you watch this little snippet here.
Where we make statistics count. I'm a computational geneticist, which means I spend a lot of time trying to find patterns in piles and piles of data. I like to think of myself as pretty good with numbers, but I need a way to figure out if what I think is a pattern really is. And that's when I turn to statistics. It's a way to organize and analyze the data I've gathered and draw conclusions from what I've found. For me, statistics is essential for my work. But statistics certainly isn't just a fancy scientific tool useful only to PhDs. Statistics is vital to people at all levels of fields as wide-ranging as business, medicine, agriculture, politics, and yes, all kinds of sciences, including engineering. Even if winning a Nobel Prize in science isn't one of your long-term goals, understanding statistics is an important part of being an informed citizen and being able to evaluate decisions that affect you. Statistical literacy is a crucial part of modern life. Here in Against All Odds, we'll show you how statistics is being done out in the world by real people. Military personnel measuring soldiers to find out what sizes of gear today's army requires. Clerical workers analyzing salaries to fight for a fair pay structure. Resource managers predicting how much water they'll have in the spring based on how much snowpack they measure in the winter. These examples all use descriptive statistics. They collect, organize, and summarize the data and do calculations to figure out what story it can tell. A big part of descriptive statistics is presenting the data in an informative way. In Against All Odds, we'll learn a variety of techniques to tease visual meaning from stacks of numbers. And you'll see statistics is flexible enough to apply in all kinds of contexts, from hot dog calorie counts to a city's census findings to bird migration dates. Once we get a handle on descriptive statistics, Against All Odds continues on to inferential statistics. Inference is a powerful way to draw conclusions about a population based on just a sample. Again, we'll go on location to learn how this technique is actually being used out in the world. We'll see how factories, like this potato chip plant, sample their products for quality control. After all, they can't test the quality of every chip, or they'd have nothing left to sell. At a survey center, pollsters sample citizens to estimate the entire public's opinion.
Are you currently employed full-time?
Since it's impossible to ask every single American how they feel about a particular issue or candidate. And of course, there are techniques to figure out how reliable these kinds of conclusions are. We'll investigate ways to quantify our confidence level and whether the results we come up with are actually significant. Is there a real difference in the daily calories used by hunter-gatherers versus Western office workers? Did Shakespeare really write a newly discovered poem? Was the chemical DDT responsible for crashing the peregrine falcon population? Stay tuned and you'll see how statistics helps answer these questions. We'll talk about probability too. That's the mathematical way of thinking about chance behavior. So come with us to the casino to learn about the odds of winning at the table. We'll also look at how probability helped the analysis of what went wrong when the Space Shuttle Challenger exploded, and how probability can assess the chance that a genetic trait shows up in one family's children. Against All Odds will provide you with a strong foundation to understand the statistics you'll encounter in your own life. Just reading the day's news, it's important to be able to decide whether the numerical claims in an article are reasonable. Does what you see in a chart or graph make sense? Sometimes you'll be faced with a choice, along with data that could help inform your decision. You'll want to know how to weigh the information that a recommended medical procedure has a 20% rate of complications, or the finding that only 30% of graduates in a certain major find jobs in their field right away. Or maybe you just want to put together a winning fantasy football team based on all the players' stats. We're confronted with these kinds of data points all the time. Understanding how statistics works lets you use this kind of information effectively. We live in a world of endless variability, and statistics is the art and science of making sense of it all. Gathering, organizing, analyzing, and drawing conclusions from data is the name of the game. Stick with Against All Odds and we'll show you how it's done, in schoolwork, in careers, and in life. I'm Party Sabetti, and I'm excited to be your guide for this series.
So as Party mentioned in that quick video from Against All Odds, there's different definitions. And one of the big things she talked about, two big definitions she talked about, were descriptive statistics and inferential statistics. So descriptive statistics, as she mentioned, organizes and summarizes data. So we can use things such as bar charts or pie graphs or circle graphs, and there's lots of different graphs that we're going to be able to use throughout the course that you will see. And then we're going to use inferential statistics, and this is where we draw conclusions from our sample data about our populations. So after we study probability and probability distributions, we can use different formulas and other formal methods to draw conclusions from our sample data. So the goal of statistics is not just to perform all these different calculations using formulas, but to gain an understanding of our data. So the calculations can be done using a calculator computer. So we're going to use the TI-8384 quite a bit in this course. So it's not so important to memorize or be able to plug in so much the formulas. We'll use our calculator to help us there, but it's really understanding our data and what it's telling us. So if you can thoroughly grasp really the basics of statistics, then you'll be more confident in some of the decisions you need to make. So we're going to use probability. Once we have descriptive statistics describing our data using graphs and charts, then we have to understand probability so that we can do this inferential statistics. And probability is a mathematical tool that we use to study randomness. It deals with chance, or the likelihood of an event occurring. So for example, if we toss a fair coin 4 times, we might not get 2 heads and 2 tails. But we know the chance of getting heads is 1/2. So if we toss the same coin 4,000 times, the outcome gets much closer to half heads and half tails. So we're going to show this when we talk about probability. So our statistics is really based on the theory of probability. And the theory of probability began with study of games of chance, such as poker, and predictions can take the form of probability. So to predict the likelihood of an earthquake or rain, or whether you get an A in this course, we use different probabilities. Doctors also use probabilities to determine chance of a vaccination causing the disease the vaccination is supposed to prevent. So let's look at some other key terms when we're dealing with statistics. Generally, we want to study a population. Population is a collection of persons, things, or objects that we're studying. So for example, if we're interested in knowing if Road State College students drive more than 20 miles to campus, we're trying to determine something about Road State College students, then our population would be all Road State College students. Right? Now, we may not be able to ask all Rhodes State College students how far they drive to campus, so we may do a study and we select a sample. So the idea of sampling is to select a portion or a subset of this bigger population and just study that portion or sample to gain information about our population or the whole thing. So if I take a sample, let's say I have 40 students in the statistics class this semester, and I ask you all how far you drive to campus. So you would be a subset or a portion of all of my population. So you would be my sample, the 40 students in this statistics class, and my population would be all Rhodes State College students. So a parameter is a number that belongs to the population. It takes a lot of time and money to examine an entire population, and that's why sampling is so important and such a practical technique. So the parameter I might be interested in is the average distance that all Rhodes State College students drive to campus. Okay, or the average distance Rhodes State College students live from campus. So a statistic is a number that represents a property of the sample. So for example, before we talk about this one I have here, when we're talking about if I ask all of my students, the 40 students in this statistics class, and I calculate the average that you drive to campus, the average of my sample is called a statistic. So a variable is noted by capital letters such as X and Y and is a characteristic of interest for each person or thing in the population. So in the example I was talking about, this might be the distance a student drives to campus, or distance a student lives from Rhodes. Okay, and that's our variable of interest. So variables tend to take on either numerical or categorical values. So here's some examples. Numerical variables take on values with equal units such as weight in pounds and time in hours. Categorical variables are person, thing, or category. So we're going to talk about what numerical variables are and what numerical data is and what categorical data is in a little bit. This is just talking about the different types of variables. So once we determine what our variable is, data are the actual values that the variable takes on. So they can be numbers or they can be words. Datum is a single data value. So for example, when I'm collecting how far students drive from campus, I might ask also I may also want to know what's the most popular color of a car. So I might ask you, number one, how far do you drive from campus? And your answer is a measuring number, right? 12 miles, 14 miles. Whereas if I ask you what kind of what color car you drive, if you say red, that's a category. So the data you actually collect really helps you determine whether that variable is categorical or numerical. So we're going to talk about what these are here in the next section.